Good morning. I was wondering if anybody was going to say anything. Nobody has said a word since I entered the room like 5 minutes ago. Okay. In any case, today we're going to talk about inverse trigonometric functions. Okay. So this is kind of like the final. I know I said that trigonometric functions were like the final class of functions, but really this is the inverse trigonometric functions are kind of something else entirely. So so this is really the last class, the last bunch of transcendental functions that we'll encounter in this course. Okay. So and they're kind of interesting. Inverse trigonometric functions. Okay. So let me just start off by asking, when can we invert a function? What kind of functions can we invert? How do we know if we can invert a function or not? Can you invert all functions? No. What functions are not invertible? Stella?
I forget exactly, but was it ones that don't pass the horizontal line test?
That's right. So if you have something like the squaring function, say, then there are two values. I'm sorry. There are two values that end up with the same, two inputs that end up with the same output. And so if you wanted to go backwards, right? If you're making an inverse function, you want to go backwards from the output back to the input. Right? And so if somebody says the output is 4, then you have no idea what the input is. It could be -2 or it could be +2, right? And so if it fails the horizontal line test, if it's not 1-to-1, right? If the functions is not what we call 1-to-1, then it's not invertible, right? And it's not invertible, right? If it fails the horizontal line test, it's not invertible. Well, we're talking about the things like what about the sine function? Is that a 1-to-1 function? If I say that the sine is 0, can you tell me what the input was? The output is 0. What was the input? So remember what the sine is, right? The sine tells you is the y-coordinate, right? The sine is the y-coordinate of your angle, right? So if the sine is 0, what could the input be? What are possible inputs, say?
0 and pi.
0, pi. Yeah, 0 would work, pi would work. Anything else? You can keep on going, actually. So we actually keep on going around. So 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, etc., etc. And going backwards, -pi, -2, -pi, -2 pi, -3 pi, -4 pi, etc., etc. Right? The sine function looks like this, right? Right? And going backwards like this, right? So at right, 0, pi, 2 pi, 3 pi, -pi, -2 pi, etc., etc. Right? It's very much not a 1-to-1 function. It's an infinite to 1 function, right? Like this function, this function, the squaring function is for the most part, except at the origin, it's 2-to-1, right? 2 values get back to 1 value. Right, but the sine function is much worse than that, right? It's got infinitely. If I say the output was, right? Think about the horizontal line test. We fail it, spectacularly, right? There's infinitely many points that are going to intersect this horizontal line. Okay. So what you should say when we start talking about inverse trigonometric functions is, what? Right? Like this shouldn't be possible, right? And it's not. You can't invert the sine function. Okay. But what we do instead is we force it to be invertible by saying, okay, we're going to just restrict ourselves to a place where it is invertible. So we restrict the domain. Okay, we say let's chop off the function so that it lies between negative pi over 2 and pi over 2. Okay, we restrict the domain, and in that domain it is 1-to-1. Right? In that domain it is 1-to-1, right? Because we've only got one value, we pass the horizontal line test wherever. Okay, and so that's how we define the inverse sine function. Okay, so okay, so what do we do? Consider the sine function, but restricted to, and this is negative pi over 2 pi over 2. Okay, so this line means restricted to. Okay, in other words, the sine function, but going from negative pi over 2 to negative 1, 1. Okay. Right. So thinking about our original definition of it, right? It's basically we're saying we're only going to take angles that lie in the right side of the plane here. Okay. Right. Okay. So in that case, then this function, this restricted function, has an inverse function, has an inverse, which we denote as sine inverse. Okay, so sine inverse, and it goes from negative 1, 1 back to negative pi over 2 pi over 2. Right? So the sine function restricted here, has its image this, and then the inverse function is going to go backwards from here to here. Okay. So this is a little bit sloppy in notation because this isn't really the sine. This is the restricted sine. But just so you have to remember that basically every time you see this thing, you have to think, oh wait, this is not really the sine on the whole. This is not really the sine on the whole domain. It's we're inverting the sign that's restricted to negative pi over 2 pi over 2. Okay, so what this means is, sine inverse of x means the angle in negative pi over 2 pi over 2 whose sine is x. Okay, so so as long as that is for x in so for x in, let's say, negative 1, 1, and y in negative pi over 2, we have that sine y equals x if and only if y equals sine inverse of x. Right, and then we have the things that you expect, right? That sine inverse of sine y equals y, and we have that sine inverse of x equals x. Right, so we have the kind of regular things that you would expect an inverse to do. Okay. The standard of inverses. Right? That, yeah, this is we've seen this sort of thing before, right? Inverses cancel each other out. Right? Okay. So let's just do some examples to make this. There's a lot of talking, but this is actually pretty simple. Not completely simple, but it's fairly simple. So let's do some examples. Okay. So if I say, for example, sine inverse of root 2 over 2. Okay. Think about that for half a minute and tell me what that means. Sine inverse of root 2 over 2. Okay, talk to somebody nearby and say, that means, what does that mean, and what is it? What is it? Isa, do you mind coming up and talking with somebody, if you don't mind?
Like the where it's
Amy, it's you.
We said pi over 4 and negative
Pi over 4 and negative pi over 4? So there should only be one, right? There should be only one value, right? Because this is a function. The function's not going to have two values, right? So let's think about. So why do you say pi over 4 and why do you say negative pi over 4?
We said pi over 4 because the sine of pi over 4 is square root of 2 over 2.
Mm-hmm.
And then we thought it was also negative sine over 4 because, or negative pi over 4 because that is also equal to the square root of 2 over 2.
So let's think for a second. Pi over 4, the sine is root 2 over 2, but negative pi over 4, the sine is the y coordinate, right? So it's actually going to be negative root 2 over 2, right? So not negative pi over 4, but just pi over 4 will do. Okay. So yeah, great. It's pi over 4. Okay. Right, because this is the angle, right? Let's just translate this into English, right? The angle in negative pi over 2, the angle on the right side of the plane whose sine is this, right? So translation, this means the angle in the right half of the plane whose sine, right, the y coordinate of the point on the unit circle is root 2 over 2, right? And there's only one angle that does that. Okay. Anybody have questions about that? Any other questions? Okay. My next question was, what about sine inverse of negative root 2 over 2? But you've already answered it, right? So sine inverse of negative root 2 over 2 would be negative pi over 4, right? Because that's the angle between negative pi over 2 and pi over 2 that has that sign. Okay. So that was number 1. Number 2. What if I say sine inverse of 2? Think about it for 10 seconds, and then talk to somebody. Okay, talk to somebody.
That's where y equals 2.
Okay, what's the answer? The answer is, it doesn't make any sense, right? This is nonsense. Yeah, so I saw a lot of you going like this, and that's the right answer. Like, what? No, right? So, because the translation of this is the angle whose sine is 2, right? That would mean that there's a point whose y-coordinate is 2, right? But there's no point on the unit circle whose y-coordinate is 2. That's just nonsense, right? No nonsense. Okay. Next one, sine inverse of sine pi over 2. So think about it for, say, 20 seconds. Okay, and then talk with somebody. Talk about it. Okay, what's the answer? Anybody? Pi over 2, right? Because you know that within as long as this thing is within negative pi over 2, these guys just cancel each other out, right? Or if you weren't thinking like that, then you could say, let's see, what is the sine of pi over 2? The sine of pi over 2 is 1, right? And then sine inverse of 1, I have to look for the angle in negative pi over 2 whose sine is 1. Okay, that's pi over 2, right? So that would be kind of the slow way of doing it. If you didn't just think about, these guys are inverses. Okay. Okay. Last one, sine inverse of sine 5 pi over 2. Okay, think about it for 20 seconds again. Okay, talk to somebody.
Yeah.
Melanie, I've rolled on you. Do you have nope, you don't? That's okay. Anybody, should I roll again? I'm gonna roll again. Jocelyn.
I got 5 pi over 2.
5 pi over 2, okay, why do you think that?
Because it'd be kind of like the same scenario as the one before where it cancels out.
Okay, so you've fallen for my trick. So there was a trick involved with this one, and I'm afraid you fell into it. So the thing is that these guys are inverses as long as the input is in the right place. But if they're not in the right place, then something strange happens. Okay, so let's see what happens. Let's think. So what's the sine of 5 pi over 2? 5 pi over 2. So 5 pi over 2 is 4 pi over 2 plus pi over 2, right? Okay, so 4 pi over 2 is just 2 pi, right? So we go all the way around the circle, and then we go another half, okay? Is that okay? Yeah. Right. So what's this? What's the sine of 5 pi over 2 then?
Positive?
Yeah, it's positive, but it's the, remember, it's the y coordinate of this point on the unit circle. So then what's the y coordinate here? Well, it's just,
Pi over 2. Or 1.
it's 1. It's 1, right? The y, you need the y,
Oh, you
the y
need the
coordinate.
one.
Yeah. Okay. So this would be sine inverse of 1. Okay. Right. And then you say, okay, well, sine inverse, what does sine, so what does sine inverse of 1 mean? Sine inverse means the angle in negative pi over 2 whose sine is 1, right? The angle between negative pi over 2 whose sine is 1, right? Well, what angle in that range has a sine of 1? Pi over 2, right? So this is going to be pi over 2. Okay, right. So this was the cautionary example, and sorry, Jocelyn, you fell into it. It was made to trick people. Yeah. Yeah. Maybe we shouldn't make examples to trick people. But, anyway, okay. But yeah, no, yeah. So this. Keep this in mind, right? Keep this in mind that you know, if your angle is lying outside, you know, that this inversion only works in the proper range, basically. Okay. Okay. So what you want to keep in mind is what things mean. Okay. Always keep in mind, you know, what does this mean? What does this mean? So like, you know, that was kind of the slow way of thinking here, and in this case, the slow way of thinking pays off, right? You say, what's the sine of pi over 2? Okay, well that's the y coordinate of this point here, so that's 1, right? What's sine inverse of that? Well, that's the point in negative pi over 2 whose sine is 1, so that's pi over 2, right? So keep in mind the meaning of things. Okay. Okay. Let me do a kind of kookier example from the book. So here is the kooky book problem. So it says, suppose you know that the sine of theta is x over 3. Okay, and that theta lies between 0 and pi over 2. Okay, and they say express theta minus sine 2 theta in terms of x. Okay. Okay. So how are we going to express, does anybody have an idea about this? How would we express theta in terms of x? Well, sine theta is x over 3, so what's theta? Stella?
Could you maybe apply sine for the inverse of sine?
Yes.
To the west side?
Yes, exactly. So you say, okay, you know, this is good. It's in the range. The sine inverse is going to return this. So we just say, look, this is going to be sine inverse of x over 3. Right? Theta is sine inverse of x over 3. We do have to be a little cautious and make sure that our theta actually lies in the range that it should be in. Okay. Okay. So sine inverse of x over 3. And then we've got this minus sine 2 theta, right, where theta is sine inverse x over 3, right? Theta is sine inverse x over 3. So this, you know, this would be a reasonable answer. Okay. You know, sine inverse x over 3 minus sine of twice sine inverse x over 3. Okay. That's a reasonable answer. It's not the answer that the book wants, though. The book wants you to use the double angle formula. Okay, so double angle formula, remember what the double angle formula says. Sine of 2 theta is actually 2 sine theta cosine theta. Okay, so let's use that. This is going to be 2 sine theta cosine theta. Two sine theta cosine theta. Okay. Okay. What's this? Sine of sine inverse. Sine of sine inverse x over 3. That's just going to be x over 3. So we get 2 times x over 3. And then we've got this thing, cosine of sine inverse x over 3. Okay. So this one is a little bit, this one you can simplify using the Pythagorean theorem is how you do it. You say, okay, look, I know that, let me just call this thing theta for right now, because it's, so I don't have to keep on writing it. Okay. So I know that the Pythagorean theorem says to me, Pythagorean identity, we know that sine squared theta plus cosine squared theta equals 1. Right? So cosine of theta is going to be this plus or minus the square root of 1 minus sine squared theta. Right? So I'm going to write this thing here as the square root of, well, plus or minus the square root of 1 minus sine squared of sine inverse x over 3. Okay. But we just said what this was, right? Sine of sine inverse x over 3 is just x over 3. So we just get the square of that here. Okay. So this works out to sine inverse x over 3 minus 2x over 3 times the square root of 1 minus x squared over 9. Let me say that again, because I think maybe I went a little bit, I think I can say it a tiny bit more clearly. Let me say it again. Okay. So we have that this theta minus sine of 2 theta, we can write as theta minus 2 sine theta cosine theta. Right? Okay. Right, which is the same as theta minus 2 sine theta times the square root of 1 minus sine squared theta, right, by the Pythagorean identity. Okay. Oh, and I should say that this cosine is going to be positive. How do I know that the cosine is going to be positive? Anybody see why I know that the cosine is positive? Fern?
Because it has to be in the right quadrant.
Yeah, this is in the first quadrant, so the cosine is positive. Yeah, so I don't have to worry about it. I don't have to worry about the plus or minus here. Okay. Okay. So this is this, right? Right, and theta is sine inverse of x over 3. Right. That's from here. And we know that sine of theta, right? Sine of theta is x over 3. Right? Sine of theta is x over 3. So we're just going to write this in. This is going to be 2x over 3 times the square root of 1 minus x over 3 squared. That's it. Okay. Sorry to have made it so complicated before. It's the same thing. It's just I kept the theta longer to make it neater. Okay. Any questions about that? Okay. Talk to each other for a minute. Talk to each other for a minute and see if you have come up with any questions. Okay. Any questions? No? 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 Okay. I had a good friend at Pomona in the math department, and she would actually ask her students to ask one random question every day, like one non-mathematical question every day. I hadn't introduced this policy in my other class, but in my other class, somebody asked, for example, how many white shirts do you have? That would count as a random question.
I do have a question.
Yes.
It's okay to leave the inverse sine of x over 3 like that?
Yeah, you can't really do much. You can't really go much further than that, right? Like these guys, it's a little bit. You could put that theta. You could substitute this in for theta and say I'm done, but you're kind of not done because you haven't simplified as far as you could go. But this you can't really simplify any further. So, yeah, the question of how many white shirts I have has actually been asked over the years multiple times.
And what's the answer?
I don't know, actually. My wife says it's 30. I don't think so. I don't know. It's not true. Not true at all. I think, yeah, exactly. Well, I've got all these white shirts that my mom left me. Yeah, it's not 30. It's not 30. Okay, so other inverse trigonometric functions. We've got the inverse cosine. Yeah, my wife hates the number of shirts I have, so that's why she said 30. She exaggerated because of her hatred. Okay, so so the cosine looks like this. Doesn't it's the shift of the sine, right? It looks like this, right? So this is pi. This is pi over 2. Right, sorry, 3 pi over 2, and coming back up to 2 pi here. Right. Okay. So what do we want to do with this? Do we want to restrict to pi over 2, negative pi over 2 pi over 2 in this case? No, right? You see that if we did that, we're still going to fail the horizontal line test, right? So instead, we restrict to 0, comma pi. Okay, so we invert here. So cosine on 0 pi to negative 1, 1 is invertible. And we call its inverse cosine inverse. Although that's really cosine restricted to 0, comma pi inverse. Really, it should be written something like cosine of the restriction to 0, pi inverse. That's probably the precise way of writing it. But we just hope that people will remember it, and then just write this. Okay. So same sort of thing, right? As long as you're in the right places, then these guys invert each other, et cetera, et cetera. Okay. So I'm not going to do too much of this. Cosine inverse of -1 is what? So let me write it in English first, right? It's the angle in 0, pi whose cosine is -1, right? That's how you, again, translate mathematics into reality, right? It's the angle in -0 pi, the angle in 0 to 0 pi whose cosine is -1, right? So what is that? What angle in 0 pi has on the unit circle an x-coordinate of -1?
Pi.
Pi, right? Because just translate what this means, right? You're looking for the angle. You're looking for the angle on the unit circle, whose x-coordinate is -1. Well, that's going to be over here. So that's going to be an angle of pi. Okay. Similar. I know I said maybe we shouldn't give trick questions, but here's the same trick question. Cosine inverse of cosine 5 pi over 2. So think about that for a minute. Okay, talk to somebody. Okay, Stella, the magic icosahedron has come up on you.
We were just thinking pi over 2 again.
Pi over 2, yep, it's just going to be pi over 2 again, right? Because this is the angle in this range that has the same cosine as that of 5 pi over 2, right? The angle in 0 pi that has the same cosine as that of 5 pi over 2. Well, that's going to be pi over 2. Okay. Another one. What's the sine of cosine inverse of y? Y is some number in the proper range. Okay. What do people think about this? So we'll approach this in exactly the same way that we did over here, right? So we're looking at the sine of this thing, cosine inverse of y, and what we'll use is the Pythagorean identity. Okay, so the Pythagorean identity says sine squared plus cosine squared equals 1, right? So cosine is again, as it was before, plus or minus the square root of 1 minus the sine squared. Right? Okay. Cosine, this cosine inverse, what is the sign of it going to be positive or negative? Let's think. Where does this lie? Cosine inverse, we know, lies in this range here, right? Right, so it's in the upper half plane. What's the sign of an angle in the upper half plane? Positive or negative? Positive, right? So we don't have to worry. It's going to be positive. Whoops. Sorry. I've got it backwards. Why am I doing this? We want the sine of something. Sorry. Sine squared. Sine is, of course, this plus or minus the square root of 1 minus cosine squared. Yeah. Sorry. Okay. And as we just said, it's going to be positive. Okay. So what do we get? We're going to get, right, sine of this thing, sine of cosine inverse is this positive square root of 1 minus cosine of that squared. But the cosine of that angle is y, right? The cosine of the of this angle is y. So we get 1 minus y squared. Okay. Those of you who have learned your trigonometric functions in triangles, here's kind of a useful mnemonic, a memory trick. You think like this, okay? You think, okay, my angle is cosine inverse of y, right? So that tells me that adjacent over hypotenuse is y, right? Those of you who did things, you know that the y coordinate, you know that the y coordinate is going to be y. I'm sorry. Adjacent, sorry. Adjacent over hypotenuse, right? Right. Okay. You know that not the y coordinate, but you know that the x coordinate is going to be y, right? Because this is the angle whose cosine is y, right? And then you use the Pythagorean theorem, right? You know that this thing over here is going to be the square root of 1 minus y squared. Right? Because this squared plus that squared has to equal to 1. Right? And so we're looking for the sine of that, right? So then the sine of that angle is going to be the opposite of a hypotenuse, which is 1 minus y squared. Okay, so if you want to think like that, that's fine. But this is kind of, either way is fine. Either is fine. Yeah. Right, so let me just say it again from here, right? If we're looking for the sine, of cosine inverse of y, we use the Pythagorean identity and say, oh look, sine is just this thing, and we figure out the sine because we figure out if it's positive or negative based on where it lies, right? And then we just say, okay, cosine of cosine inverse is y, so we get a y squared here. Okay. Okay. So there's one last function, which is the inverse tangent function. Okay. We haven't really talked about the tangent function. Inverse tangent function. what's the tangent function? I'm hoping that you have read it in the book, but what is, can somebody tell me the tangent? What's the tangent? Sine over cosine, right? So tangent is defined as the sine over the cosine. Okay, right. And if you think about it on the, in terms of our unit circle way of thinking, right? That's going to be, if I have an angle, sorry, let me use theta here, so I can use x's and y's over there. Okay, if I have an angle theta, then the tangent is going to be the y-coordinate over the x-coordinate, right? It's the y-coordinate over the x-coordinate, right? So, like here, it's going to be this y-coordinate, right? This y-coordinate divided by this x-coordinate here, right? Because that's the sine, and that's the cosine, right? So what it gives you is actually the slope of this line. Okay, if you want to think about it geometrically, it's the slope of this line. So tangent of 0 is the slope of this line, which is 0. Right? Tangent of 45 degrees is the slope of this line, which is 1. Right? Tangent of pi over 2 is infinite. Right? Positive, it heads off towards positive infinity. It doesn't have any value. It's the slope of this line, which doesn't really have any value. But as you see, it gets closer and closer to positive infinity on this way, and closer to negative infinity as you go this way. Okay, so the graph of the tangent line looks like this. As you get closer to pi over 2, so let's see, at pi over 4, it's 1. So 1 is somewhere around here. Okay, so at pi over 4, it's 1, right? At 0, it's 0. At pi over 4, it's 1. Right, and then at negative pi over 4, it's -1, and then as you head off towards pi over 2, it goes upwards towards infinity. Okay, and then it's an odd function going down like this. Okay, and then once you cross the line, you get back to negative infinity, you head back to 0, et cetera, et cetera. It actually repeats like this. So every pi, so this is 3 pi over 2. This is negative 3 pi over 2. Okay. So this is what the tangent function looks like. Okay. And it's it's important. Okay. Okay. So, is this an invertible function? No. Right. So again, we're gonna do our check. Where should we restrict to? Zoe?
Negative pi over 2 to pi over 2.
Yeah, negative pi over 2, pi over 2, right? I mean, so I should say that all of these restrictions are kind of arbitrary, right? We could have restricted to pi over 2, 3 pi over 2. For the cosine, we could have restricted to, we could have restricted to pi comma 2 pi or something like that. But there are certain conventions. Basically, you choose the one that has 0 in it. Okay. So yeah. So we play the same game. Tangent, if we restrict it to negative pi over 2, pi over 2, with the open brackets because we can't take values at the endpoints. That would be infinite. Going to the whole real line is invertible. It's 1-to-1. So we can invert it. And we get some function which we abbreviate as tan inverse going from the whole line back to negative pi over 2, pi over 2. Okay. And again, on that range, it does what it should. Okay. The graph the graph of it looks like this. Right, it's the reflection of the other graph. So going from negative pi over 2 to pi over 2. Okay, and okay, I don't have time to do the example, but please read the example in the notes. Okay, so the example in the notes is pretty similar to the previous examples. Okay, that's it for today.